Hi everyone, this is Mrs. GA, and today we're going to talk about isosceles and equilateral triangles. So let's start with isosceles triangles. So an isosceles triangle is a triangle with two congruent sides. So you can see here we have a picture of an isosceles triangle, and we have two congruent sides shown by these little tick marks. The congruent sides we call the legs, and the vertex angle is always the angle that's between the two legs. So again, the vertex angle is between the two congruent sides. The side that is opposite the vertex angle, so if I go across, we call that the base of our isosceles triangle. Now it's not always on the bottom because it depends where your congruent sides are, but it is always opposite of the vertex angle. And last, the base angles are always opposite the legs. So if I know that this is a leg, I look opposite, and that's a base angle. Here's my other leg, opposite is the base angle. So it's really important that you know how to define the different parts of an isosceles triangle, so we can use what's called the Isosceles Triangle theorem. So this theorem says if two sides of a triangle are congruent, then the two angles opposite the sides are congruent. So again, those would be the base angles. But here we can make the statement that angle B is congruent to angle C. So to generalize, we can say in an isosceles triangle, the base angles are always congruent. Now, the converse of that statement, remember the converse is when you switch the if and the then of a statement. This one says if two angles of a triangle are congruent, so now we're starting with the angles, then the two sides opposite those angles are congruent. So here we're saying if we know that angle B is congruent to angle C, then we can make the statement that side AB is congruent to side AC, which would be the legs of the isosceles triangle. So again, the first one says if the sides are congruent, then the angles are congruent. And the converse says if the angles are congruent, then the sides are congruent. So now we're going to take a step away from isosceles and talk about what's called an equilateral triangle. So an equilateral triangle is a triangle with three congruent sides. So all three sides are congruent. Now an equiangular triangle is a triangle with three congruent angles. Okay, so the first one describes congruency with the sides, the second one describes congruency with the angles. So the equilateral triangle theorem says that if a triangle is equilateral, then it is equiangular. So here we see that the three sides are congruent, so then we can conclude that the three angles are congruent. Now the converse of that, remember we switched the if and then. This one says if a triangle is equiangular, then it is equilateral. So this time we know that all three angles are congruent, so we can conclude that all three sides are congruent. So remember the first one, it says if the sides are congruent, the angles are congruent. The converse says if the angles are congruent, then the sides are congruent. All right, so let's see if we can now use what we know about isosceles and equilateral triangles to help us find x in the following figures. So here you can see that I have a triangle with two congruent sides. So this is an isosceles triangle. So an isosceles triangle, again, we know that the opposite angles are going to be congruent. The angles that are opposite the congruent sides. So if this angle is x, then I know that this angle is also x. So now, using the triangle sum theorem, we can make an equation to help us solve for x. So we know that the sum of the interior angles of a triangle is 180 degrees. So here, let's combine like terms, and I'm going to subtract 30 from each side. So x equals 75. So there you go. However, you do have to know that this is an isosceles triangle, which means these two angles are congruent. All right, let's try this next one. So here I see that I have a triangle with two congruent angles. So using the converse of the isosceles triangle theorem, I can conclude that these two sides are congruent. And again, this is also an isosceles triangle. So since those two sides are congruent, I can say x plus 5 equals 2x minus 4. And I'll subtract x and add 4 to both sides. So 9 equals x. So again, you have to recognize that if these two angles are congruent, then their opposite sides are also congruent. That's the converse of the isosceles triangle theorem. All right, let's look at example C. So here we can see that we have two angles given. We know this angle is 56 and this is 62. Let's see if we can find this missing angle here. I'll call it y because we already have an x. And let's see what we can find out. So we know that 56 plus 62 plus y should equal 180. So here we can combine like terms. We get 118 plus y equals 180. So y equals 62 degrees. So if y is equal to 62 degrees, well, that means that these two angles are congruent. So we know that this is an isosceles triangle. And in an isosceles triangle, we know that the opposite sides are also congruent. So we can make the statement that this side is congruent to this side. So we'll say that x is equal to 42 meters. So again, make sure you find that missing angle before you make any conclusions about what type of triangle it is. Again, if two of the angles are congruent, then we know it's isosceles, and we know that the opposite sides are also congruent. Okay, let's try this last one together. Here I see that PR is congruent to QR. So I know this again is an isosceles triangle. And since these two sides are congruent, I know that the opposite angles are going to be congruent. So angle P is going to equal angle Q. So that means that angle Q is also going to be 3x plus 2. Now here we can solve for x using the triangle sum theorem. So we know that all three interior angles should add up to 180 degrees. And this equation should allow us to solve for x. So let's start by combining like terms. Here I have 11x, and I have 2 plus 2 minus 11, so minus 7 equals 180. So here we get 11x equals 187, and if I divide both sides by 11, I get x equals 17. So again, an important step here is recognizing that this is an isosceles triangle, therefore the angles opposite the congruent sides are also congruent, and that allows us to set up this equation. All right, let's have a look at this next example. This says Katie's tutorial service is going so well that she's having t-shirts made with the equilateral triangle emblem. She has given the t-shirt company these dimensions. What is the length of each side of the triangle in centimeters? So you'll see, first thing you should notice is that in this triangle, we have three congruent angles. So this is an equiangular triangle, which means that the sides are also all congruent. It means it's also equilateral. So since the sides are all congruent, we know that AB is congruent to AC. So we can set up an equation. We know that 3/10 y plus 1 equals 4/5 y minus 4. Now here I'm going to clear our fractions by multiplying both sides by the least common denominator, which would be 10. So if you multiply every single term by 10, that leaves you with 3y plus 10, right? This 10 cancels out this 10. 10 times 1 is 10. Here, if I multiply it here, 10 divided by 5 is 2, times 4 is 8. So this gives me 8y minus 4 times 10, which is 40. Now, you don't have to do this to solve, but it's a step that I always recommend taking whenever you have a fraction because it makes the problem much easier. So let's add 40 to both sides and subtract 3y from both sides at the same time. And we end up with y equals 10. However, they didn't ask to solve for y. They actually asked for the length of each side of the triangle. So now I'm going to go and substitute this in here or here. All lengths are the same, so it doesn't really matter which one. Let's substitute it into AB. So we have 3 over 10 times 10 plus 1. 10 divided by 10 is 1, so it simplifies to just 3 plus 1. So it's equal to 4. So all three side lengths are 4 centimeters. Because again, because it is an equiangular triangle, it is also an equilateral triangle. All right, let's have a look at example 3. Here we are given that triangle JKL with measure of angle J is 66, measure of angle L is 48 degrees. Let's draw a quick picture of this. JKL, so we'll call this 66 and we'll call this 48. Is this triangle an acute, isosceles, obtuse, or right triangle? So acute, remember we've talked about acute angles before. Acute means less than 90 degrees. So it will be acute if all of the angles are less than 90 degrees. We know that isosceles means that 2 of the sides are congruent or 2 angles are congruent. Obtuse, of course, means greater than 90 degrees. Greater than 90. So we call it an obtuse triangle if one of the angles is greater than 90 degrees. And then we know that a right triangle is when one of the angles is exactly 90 degrees. So we're going to need to find that missing triangle to help us determine this missing angle to determine what type of triangle it is. So we'll do 66 plus 48 plus angle K equals 180 degrees. So here this gives us 114 plus angle K equals 180 degrees. So angle K equals 66 degrees. So if you look at what we have going on in this triangle, all 3 of the angles are less than 90, so we could call this an acute triangle. However, you might also notice that angle J is congruent to angle K. So that means that this is an isosceles triangle. However, we could also classify it as acute because all 3 of the angles are less than 90 degrees. Okay, we're going to try this last problem together. It requires a little bit more critical thinking, so let's see if we can figure it out. Can the base angles of an isosceles triangle ever be obtuse? Explain with mathematical reasoning. So let's say we set up an isosceles triangle, and let's say these are congruent, so these are congruent. So let's pick an obtuse angle and let's see what happens. So if this, let's even make it the smallest obtuse angle possible, 91 degrees. Okay, so let's say both of these were 91 degrees, and let's say we call this x. Let's see if this would be possible. So 91 plus 91 plus x should still add up to 180 degrees. So we get 182 plus x equals 180 degrees. So that means that x would have to equal -2. So it is not possible for an angle to be negative. Angles cannot be negative. So therefore, we can conclude that the base angles of an isosceles triangle can never be congruent, because if they are, then it doesn't work for the triangle sum theorem. There's already too many degrees in our triangle with just the bases to add up to 180. So we'll say the base angles must be acute. That's what we can conclude, and this is how we can prove it. Again, we just picked an example of two obtuse angles to see if it would work for a triangle sum theorem. It doesn't, so this is our conclusion. All right, that is all for today's video. Thank you so much for watching.